Okay, in this video we're going to be going over problem 3 off of the momentum review. So, problem 3 reads like this. We have Claude and Maud's rivals, Damien and Amy Ann. They're whipping around the ice rink with a stunning display of speed and agility. It says assume Damien has a mass of 55 kilograms and Amy Ann has a mass of 75 kilograms. They ramp up to do the signature trick, the collision, in which they demonstrate the conservation of momentum to all their loving fans. If Amy Ann starts skating towards Damien at -3 meters a second. Oh, yeah. So Amy Ann starts skating towards Damien at -3 meters a second. It says in the audience, Damien's mom records his velocity using a sonic detector like we did in the lab. So the data Damien's mom took after the collision is shown below. So it's asking what is Damien's initial velocity and what is his final velocity. I'm actually going to answer those together. So his initial velocity is really right here on the graph. So this is a velocity time graph. So really all you have to do is read off of it. So his initial velocity is like right here. It's a little hard to tell, so I'd say it's like 7.5. And his final velocity is right here, because the collision's in the middle. This is where they're running into each other. So his final velocity would be like right here. So I'd say the final velocity is like maybe -1.9. So A, his initial velocity, again, it's hard to tell real specifically. So I'm going to say approximately 7.5 meters a second. And his final velocity is approximately -1.9 meters per second. So, approximately -1.9 meters per second. And again, just a note on this problem, these two, my answers, all your answers are based off of what you got in A and B. So if you get slightly different numbers in A and B, that's okay. Just know you're going to get slightly different answers for the rest of the problem. So again, I'm going to be basing all my numbers off of these two figures, but you could have something slightly different. So the next one is calculate Damien's initial momentum. So his initial momentum will be his momentum before the collision. So C, his initial momentum. To calculate his momentum, it's the product of mass and velocity. We know his mass is 55 kilograms. It's given in the problem. We know his velocity is 7.5 meters per second. So that would give us a momentum of 412.5 newton seconds. And this is technically his initial momentum. So that's C. The next one is talking about calculate the total final momentum. So it's the final momentum of everyone together. Well, not that they're sticking together, but the final momentum of both skaters combined. So if we want to figure out the total final momentum, we really have to think about the conservation of momentum. So if we want the total final momentum, one way we could figure that out is if we knew the total initial momentum, we know that's equal to the final momentum. And we can actually find that. We actually have enough information. So the net initial momentum, or total initial momentum, is going to be the first mass. So we'll call M1, or we'll call 1 Damien, and we'll call 2 Amy Ann, just for clarity. Amy Ann. So the net moment, or the total momentum initially, is going to be the mass of Damien times the velocity initial of Damien plus the mass 2 which would be the mass of Amy Ann will be mass 2 times the initial velocity of Amy Ann 2. So again, that would be the initial, their masses and their initial velocities. So now we just got to plug in. We know the mass at Damien, 55, times his initial velocity, 7.5, plus 75. The mass of Amy Ann times her initial velocity, -3 meters a second. And we know it's -3. We know it's -3 because it says in the problem, it says he's skating at -3. So if we add that up, we know that the initial velocity is 187 Newton seconds, or 187.5 Newton seconds, and that's going to be equal to the final momentum. So the total initial momentum is equal to the total final momentum. It's 187.5. The next one would be E. Here we go. So E, calculate Amy Ann's final velocity. So Amy Ann's final velocity. To do this, we're going to again have to look at the net, or the total initial and final momentum. We just calculated total initial momentum in the last problem. We found that to be 187.5 Newton seconds. The total final momentum is going to be mass of Damien times his final velocity plus the mass of Amy Ann times her final velocity. Yep. Now we just got to plug in, keeping in mind that we're solving for ultimately Amy Ann's final velocity. Yes, so Amy Ann's final velocity. So we're going to plug everything in. 187.5 is equal to the mass of Damien, 55, times -1.9, plus 75 times the final velocity of Amy Ann. We solve it, we're going to get 517 is equal to 75 times final velocity Amy Ann. Final velocity Amy Ann is going to be 3.89 meters per second. Okay, so that is E. The next one, F, is asking, okay, well, now what's the impulse on Amy Ann? So if we want to figure out the impulse, that's going to be, that's delta P, and that's equal to mass times the change in velocity is equal to mass VF minus VI. So we're really gonna, if we want the impulse, we're really just gonna plug in the mass and each of the velocities, because we know those now. So the mass, her mass is 75 kilograms. Final velocity we just calculated is going to be 3.89 meters per second. That's going to be subtracted by her, or you're going to add the initial velocity, which is -3. So the total momentum, or not the total momentum, the impulse, the change in momentum is 67 Newton seconds. 67 Newton seconds. And the last part, what type of collision? This would be an elastic collision. And again, it's elastic. Sorry, I kind of went through that a little fast. What type of collision? It's going to be an elastic collision. And the reason it's going to be elastic is because they're bouncing off of each other. Okay, that's about it for